Okay guys, today we're doing 6.1, indefinite integration, or in common terms, layman terms, boost and divide. Let's get started. Okay, so here's the rules. It's like the power rule for integration, okay? It's just like the one we're going to do so often that you're just going to you're going to remember how to do it. It's going to be what an integral is. Okay, first off, you know what? Let's start with taking a derivative and see how would we get there. Okay, so let's say you have this original function and you're going to take the derivative of it. What is the derivative of that? It's 10x, right? Let's do another term. What if I also had 6x? What's the derivative of that? Just 6, right? Okay, now let's say I had another thing. Plus 7. What's the derivative of plus 7? Nothing, right? Okay, so how could we go from here and figure out what the original was? How are we going to go from here and go to there? Yeah? Okay, so here's how you would do it. First thing is, put the equation into terms. If you notice, I've already done that. Yeah, it's a 10x plus 6. It's in terms. Boost, then divide. Okay, here's what it means. Boost. Whatever the exponent is, in this case it's 1, we're going to boost it up 1. We're going to add 1 to it. So, we're going to go to 10x squared. Okay, boost. That's what the boost is. Then divide. Divide by whatever that new exponent is. 2. Notice that would give me 5x squared, which is what the first term is. Okay, same thing here. I'm going to boost, then divide. Well, it has no exponent. So I'm going to boost it so it has 1. Then divide, which is divide by 1, because the exponent is 1, but that's not going to do anything, so I don't need to write that. Okay, then that's all of the terms I had, right? But this one had a plus 7. How in the world would I ever get a plus 7 here? Because I already figured out the rest of the equation, right? 5x squared plus 6x. But I don't have a plus 7. And that's where this last thing comes in. Never forget the constant, which just means put a plus c. I couldn't have guessed what number it was. It could have been a 10, 5, negative 60, but it was a plus 7. So in order for us to denote that, we're just going to put a plus c for the constant. Okay? So, remember, you write it into terms, boost then divide. Don't forget about the plus c. Okay? Let's go forward and give some of these a try. Okay, first thing, let's remind ourselves, what did we learn about derivatives? We learned the power rule, the product rule. The power rule is what we just did, right? That was what we did on that last one where we did 5x squared became 10x. That's power rule. Product rule, which is when things are multiplying. Quotient rule, when things are dividing. Chain rule, when there's a function inside of a function, like a composite. And when it happens more than once. Okay, those are all shortcuts to help you take a derivative. With integrals, there's not as many, at least for Cal 1, okay? What you're going to do is, first one you learned is boost and divide. Okay, you already learned that one. We're going to practice it a little bit, but that's boost and divide. Then there's only one other one, and it's called U substitution, okay? And we're going to learn that in this chapter. So let's do some boost and divides, and then later on I'll teach you the U sub. Okay, boost and divide. Okay, we want to boost this, so we're going to make the exponent. Oh, just in case you haven't noticed this integral here, this symbol, this is an integral, okay? So this is an integral sign. That's an integral sign, and whenever you have an integral sign, it's gonna come with one of these, a d something, okay? In this case, it's an x because our function is made of x's. So this sign and this come together. This is the function, okay? This thing right here, that's our f of x. That's our function. So this is telling us to take the integral, which we're just learning right now. This is the opposite of a derivative, okay? So when you see this, that is the opposite of a derivative, and we call it an integral. Okay, so let's do boost and divide on this function right here. So we're just going to focus on the function. After we boost and divide it, these things disappear. Okay, because we did the integral, so there's no longer a need for them. Okay, so let's boost and divide it. Let's take the integral. Boost it to 5, divide by my new exponent, and then plus c. And that's my function, that's my answer. Okay, let's go over here. Okay, this and this mean take the integral, right? So I'm just going to focus on this one right here. I'm going to boost it, so now it's going to have a variable of x, and then that's all of it, that's all the terms. Now I just need a plus c in there. Okay, and that's the answer to that one. Okay, now let's do it with multiple terms on there, okay? So now we got multiple terms, we got 3 of them. Okay, we're going to do it to each one of these. Now remember, this and this are going to be gone once I take the integral. Okay, so let's boost, then divide by the new exponent. Okay, plus 6, boost, switch it from being a 1 exponent to 2, and divide. Plus 2x, because I'm just adding an x onto it, and then plus c. Remember, that and that disappeared because I took the integral now. It's gone. So that's my answer. Now you can also simplify this one, so why don't we simplify it real quick. X to the 4th over 4 plus 3x squared plus 2x plus c. And that would be my answer. Okay, I think I got a couple more here for you guys, just making them a little more difficult. Okay, write it into terms. So just like when we were doing derivatives, we can't do this integral with this on the denominator. We want it to be on the top. So I'm going to rewrite it. Remember to move it to the top. It's going to have a negative exponent. Okay, now notice this and this did not disappear because I have not boosted and divided yet. Okay, so now let's boost and divide this. Okay, so if I boost it, negative 3 plus 1 would be negative 2, divided by my new exponent, negative 2. Don't forget your constant. Okay, that's my answer, but I can rewrite it because I have a negative exponent here. It's going to be rewritten as 1 over negative 2x squared plus c. There's our answer. Okay, same thing over here. Remember, I need to rewrite it so it has exponents, just like when we were doing derivatives. Okay, now I have not taken the derivative yet, so I'm still going to have my integral sign on there. Okay, boost and divide. Okay, we're going to add 1. Yeah? Remember, adding 1 basically means adding 3 over 3. Yeah, it's going to be like 2 plus 3. So it's going to be x to the 5 over 3. All divided by 5 over 3. Don't forget your constant. Okay, that's my answer. But I need to simplify it. I can write this thing over 1, and then I got a fraction over fraction, and we can do the sandwich method. This times that, and the middles together. So the bread's together and the middle's together. Okay, so my answer is going to be 3 cube root of x to the 5th. That's what 5 over 3 is, right? That 3 is the cube root. Then 1 times 5. And don't forget your constant. And there's the integral. I believe that's all of them. Oh no, I got a couple more. Okay. So, on one like this, now I need it written in terms. Right now it looks like chain rule, right? I'm having something raised to the squared. I need to rewrite this so it's not chain rule. So in order to write this in terms, it's going to be, meaning I need to FOIL it out, right? Okay, this would be 4x squared. 4x squared minus 10x plus 25, which is the same as minus, this can be combined to be negative 20x, right? So, written in terms, I have 4x squared minus 20x plus 25 dx. Now notice, I did not take the integral yet, so I still have the integral sign and the dx at the end. Now I'm going to take the integral, and those two things are going to disappear when I take the integral. So, boost and divide. That's the first term. Now I'll focus on the next term. Minus boost, so my exponent's now going to be 2, and divide. Okay, my last term here, plus 25, I just need to give it an x. And don't forget your constant. Okay, and that's my answer. This one you can simplify to 10x squared, and that's about as much as you can do, okay? So this, the most simplified version would be this right here. And that's my answer. Okay, now one last problem here, and we're done, and you can work on your worksheet. This one right here. Now this is, it looks like quotient rule if you were taking the derivative. Oh, and it looks like I forgot to put a dx at the end of that. Okay, now it looks like quotient rule, but we don't have any rules like for quotient rule. We need to write this in terms. Okay, now remember, this thing on the bottom means it can separate into both of those. So this can be the same as 9x squared over x to the half plus 3x over x to the half. Okay? I just separated this underneath both of them, and I wrote it so instead of having a square root, it's written to the half power. Okay, now I want it in terms. This is still looks like quotient rule. I want it to just have one variable. So, remember, if there's division, you subtract the exponents. So it's going to be 9x to the, okay, this is like 2 over 1 minus 1 over 2, right? So 2 minus a half is going to be 3 over 2. Because it's like 4 over 2 minus 1 over 2, right? Plus, okay, this is the same as an exponent of 1, which is the same as 2 over 2 minus a half. So that's going to give me 3x to the positive half dx. Okay, now if you're confused at where I got these exponents from, okay, let's just look at this. I did 2 over 1 minus 1 over 2. So I did this. I was subtracting the exponents, right? 2 over 1 minus 1 half. That's the same. I need to find a common denominator. That's going to be 4 over 2 minus 1 over 2, which is going to be 3 over 2. And that's where I got that one from. Yeah? For this other one, the half, I did 1 over 1 minus 1 over 2, which I'm going to have to find a common denominator. So 2 over 2 minus 1 over 2, which is just 1 over 2. Yeah? That's where that half came from. Okay, now that was just writing it into terms. I have not taken the integral. Notice that's why I still have the integral sign and the dx at the end. Okay? I have not taken an integral. Now I'm going to take the integral. I'm going to boost and divide. So 9x. Okay, if we boost it, remember that's like adding 1. You can think of it as adding this because we're going to be adding 2 over 2. So 3 plus 2, 5 over 2, all divided by, now I'll just keep writing it like this, 5 over 2. Okay, and this is going to go over 1, so we can use sandwich method. Okay, plus 3x to the 3 over 2 over 3 over 2. Okay, now that's still written over 1. what's going to happen here is you're going to notice this thing on bottom is just going to move its way to the top. Okay, that's how we're going to constantly do those. And don't forget to put your plus c. Now that the integral sign and the dx are gone because we did take the integral, and that's our answer. I mean, we're gonna simplify it a little bit. Okay, remember it's sandwich method, which means 2 times 9. Well, I'm sorry, 9 times 2, which is going to be 18 x to the 5 over 2, all divided by 5 times 1, which is 5. So notice what's happening here, just a shortcut, is you're taking this bottom number and you're moving it to the top and multiplying. Okay, so it's going to be plus, take that bottom number, multiply with a 3, it's going to be 6x to the 3 over 2, all over 3, plus c. And we're almost done. We can just simplify the 6 and the 3 there. So it's going to be 18x to the 5 over 2, all over 5, plus 2x to the 3 over 2, plus c. And that is the integral of that problem. Okay, and that is everything that you're going to be doing on this worksheet. So good luck, and see you on the next one.